to slide around.
Yep.
We are live. Okay. All right. So good morning, everyone. Welcome to Ask the Agronomist. Very excited to have our guest with us here today. So we are live from this is ERML, you call it,
yeah,
right?
Edward R. Madigan Laboratory.
There you go. Thank you, because I wasn't sure what ERML was. When I was here, this building was not. So anyway,
That's right, Lance.
so this is
we're dating ourselves here.
So this is my first time in ERML. So we've got Adam Henniger with us as our producer. We've got Jennifer Elliott, associate producer, with us, and our special guest needs no introduction, but I'll do it anyway. Dr. Fred Below from University of Illinois. Privileged to have you here on Ask the Agronomist. Fred and I first met almost 30 years ago when I was a student in his class. Dr. Below was always one of everyone's favorite advisors and teachers and instructors. But my appreciation for Dr. Below has actually grown more in the 30 succeeding years as we've had opportunities to work together on various projects. And I followed all the great work he's done here at the university. He'll be talking some about that here today. Hopefully, if you've got questions, he'll have time to answer a few of your questions here live on Ask the Agronomist. We've also got, at the end of the episode, we're going to do our giveaway this year. So we've had a total of 38 viewer questions that have come in throughout the season, and we'll hopefully have more today that will add to our tally. Jennifer has a bucket with the names in it, and as you ask your questions in the chat today, we can add a few more contestants. Last year we gave away a few bags of corn, which that's kind of boring for seed company kind of thing to do. We've got some younger people, some hipsters on the team these days. So this year we're Jennifer's laughing at me. We're giving away a cool solo stove and the picture that we had, I think it maybe exaggerates a little bit the size of it. They do that like you see the guy with the big buck picture and the buck's laying here and he's like 15 feet behind the buck, so it looks like it's the size of a moose. I think that's what they did with that stove in that picture. So it may not be as big as one of the pictures made it look, but it is pretty neat. Got a DEKALB Asgrow logo on it, and we typically go an hour here on Ask the Agronomist, but we've driven all the way to Champaign. Fred has been gracious enough to give us his time. He has more than an hour. Adam and I have nothing to do except drive back across Illinois. So we'll probably go a little long here today. Whenever we get done, we will do our giveaway, and very excited to dive into things here. So I guess, Dr. Below, why don't you tell our audience how you got started in your career and what brought you to crop physiology?
So before I get to that, Lance, I got to show a picture, if you don't mind.
I don't mind at all.
And this is a picture of Lance in my class back in 1992. This is 30 years ago. I don't know if you could see Lance.
Is that why it's a black and white
right over
picture?
here? Yeah, they didn't even have color.
Damn.
30 years ago. So that's Lance right there with the hat on, and that's me over in the other corner. Lance, we haven't aged today, man.
No, that's right.
In that 30 years, so I'm happy to say. And I'm pretty proud that I might have had some small role in helping educate Lance. So, I'll tell the audience some secrets that I don't normally tell. But I originally was going to be a veterinarian. So I liked animals, right? And I went to Northern Illinois, and veterinarians have to go through the same path that doctors do. Mm-hmm. It was fairly hard. I mean, a lot of hard biology and chemistry, and I was doing that, and I was doing fairly well. And then I looked up that by gosh, vets don't make all that much money.
They get up in the middle of the night.
Yeah, that was a lot of work for not a lot of pay. And I looked around, and I said, geez, there's a lot of corn here, and somebody must have to study that. And honest to God, in class, one of my instructors, it was called botany at the time, and he showed pictures of nitrogen deficient corn plants. And he said the agronomists at the University of Illinois are working on this. All right. And I went right immediately to the library. I looked up agronomy. I said, that is for me.
Cool.
And I transferred down here.
Nice.
That was in 1976, actually. So I got my PhD in 83, went all the way through, got my PhD in 83. They hired me in 85. And, 39 years later, blink of an eye, here we still are.
The rest is history. So that's cool. So you advise a lot of graduate students. We've hired several of your graduate students. We're working here today with a gentleman who was one of your graduate students in Adam Henniger. And I don't know if you keep track or not, but do you know how many students you've had over your career?
I do. I counted them just the other day. And our work is done with graduate students. I hope our audience doesn't get the idea that I actually do anything. I mean, I advise the grad students who do the research. So I've had 56 students over the course of my career who've written theses.
Nice.
37 of those have been masters and 19 PhDs. In fact, today's graduation day, and I get to hood one of the PhDs later today, number 19.
Cool.
I also ran the off-campus program for 10 years, between 1996 and 2006.
Our colleague Chris Carlisle would have been one of your students in that program.
I was his advisor.
Yeah.
So I was the advisor to 73 of those guys.
Cool.
And the fun thing there is, we gave them an exam, and I got to put the fear of God in them before the exam.
Little interesting history for me. I snuck through the off-campus program when you could still do that as an on-campus student in the 90s. So I did what we called a non-thesis option master's.
I did remember that. You're like a hybrid, man.
Yeah. So that was
maybe a unicorn.
Like mythical, right?
Just like you didn't want to do all that biology and chemistry to be a vet, I didn't think I wanted to spend an extra year in grad school doing a whole bunch of research so I could publish something. So I took that non-thesis option, which no longer is an option to students on campus, as I understand it. But didn't need any foreign language when I went here either. So that's another thing that has changed over the years. So anyway.
Well, Lance, I will say I'm very proud of the students that have taken my course. Like you, when I see students that I taught being successful, I'm pretty happy, and I'm exceedingly proud of my graduate students, like Master Henniger here, who are out in the business helping farmers.
Well, and I can verify that every time we get together with your program, so you can share with us what you've learned, and you've worked with short corn with us. You've worked on a lot of our stuff over the years. You always put your students out front, and your students always do the presenting, and you do an awesome job giving your students opportunities to learn and interact with industry, and I think that's a great thing, and makes them better when they get out in industry for that opportunity. So I think
we got a question already.
All right, cool.
So Sarah has typed in good morning, and she says she wants to know what you guys think the optimal time to spray fungicide for the best yield return is, and whether or not you recommend 1, 2, or multiple applications of fungicide.
So this is cool. So you and I are up here just bantering, wasting our viewers' time, and our viewers are getting us focused back on agronomy here. So that's
good for them.
That's good, because this could go on for hours here. So it's probably good. So you want to take a crack at that one?
I will take a crack at it. And normally a few years ago, I would have told you that the optimum time is 1 time at VTR1. Okay, but that was before tar spot came in, and before some of the really bad southern rust outbreaks I've seen in the southern part of the state. So I'm gonna roughly say, the answer to everything is it depends. It depends on the disease pressure. That depends on the year. I mean, if you're pushing for 300 plus bushels, you're probably going to have to put it on twice. That would be my guess. I read the label, and it said to apply again after 25 days. Mm-hmm. And I go, well, that must mean it only works 25 days. And so what I've seen a lot of high yield growers do is put it on at VTR1 and then come back again at R3 2 times. That's going to be screaming improvement. Now I'm also a little worried about tar spot. I'm a little worried about tar spot coming in before VTR R1. Mm-hmm. We have worked with an in-furrow or not an in-furrow, a 2x2 product, FMC Xyway. I wouldn't have believed for a second that I could put something with planting that might still have activity later, and it does. Mm-hmm. And so I see a possibility of putting it on with the planter, coming back with VTR1, mm-hmm. and I'm pretty sure that's going to give me a pretty good level of control.
Mm-hmm. Yeah, and I think we've seen a lot of the same things in our trials. We've looked at V5, V6 applications very early season. That's too early for tar spot control. but there can be benefits to those early season applications. That is the cheapest, easiest time to put it on as well. Typically hitches a ride with your herbicide application. Doesn't work with all herbicide programs, so you got to be careful with your timing and tank mix partners and those sort of things. But we have too looked at the VTR1. I'm not a big brown silk guy. I've always discouraged people from waiting till brown silk, especially in the tar spot era. I think that's even a poorer idea than it used to be. That lets that disease get way too much of a jump on you, and if it gets rolling, there's not much you can do to stop it at that point. So we whether you're using a preventative or a curative product, most products have tank premixes of multiple modes of action these days. But even if you've got the best curative in the world, you need to get the product on before the disease is progressed. And so I think that focusing on that VTR1 timing, occasionally there may be benefits to something earlier. And in a bad year like we had in 21, we definitely saw benefits to that sequential R3-ish kind of at the roasting year stage timing of another fungicide. We've also been looking at rate enhancement. And as some of you know, there's a rate range on most products. There is the standard use rate, and then there is a use rate that's usually about 50% higher than the standard use rate. That's the full label rate. And we've also seen some nice benefits to full label rate applications in moderate to heavy disease pressure scenarios. So whether you want to be more aggressive by using better products, by using higher rates of products, or using more applications, those are the ways that we're looking at being more aggressive from a fungicide use standpoint. So great question. Make sure and get them added to the. Jennifer's got you added to the contest. So any other questions in the chat yet, Adam? Before we,
I think we got a couple more. I was just going to add a little follow up to that. Don't get this question very often, but occasionally do. With certain adjuvants, surfactants, and things like that, and scares of ear abnormalities. Is that much of a concern anymore, or is that something that we don't worry about?
I'll lead on that one. I'll let Dr. Belo follow up if he feels the need. There is a little bit of a disagreement in the industry about the potential for that. When that happened back in probably 2009-ish, I think was the year that injury occurred. Had a lot of arrested ear, abnormal ear, beer can ears, basically interfered with the ear development. Those applications were probably made pre-tassel, probably more at the V14-ish maybe growth stage, which is kind of a sensitive time. There were some surfactants that were implicated in some of those challenges, impurities in surfactants. People that were using either crop oil or no surfactant tended to not see the problem as much. Most fungicide manufacturers would say that cleaning up the impurities and surfactants and avoiding some of those issues make that not a concern. At Bayer, we are still a little concerned about some of those pre-tassel applications. And Dr. Belo's worked a lot with the impact that fungicides have on ethylene production and how that could be related in that situation. So I personally would prefer to be able to see some tassel before I make that VT application, or be earlier in the season than 2 or 3 weeks before tassel. So I still personally kind of like to avoid that few weeks before tassel stage. So I'd either go early vegetative or in furrow, as Dr. Belo mentioned with some other products, or wait till you've got some tassel showing before you pull the trigger on that VT application. We do encourage the use of adjuvants with fungicides. It just improves the efficacy of the fungicide. So if you take that out to improve the crop safety, you could be giving up a little bit of benefit, a little bit of efficacy. I'll let Dr. Belo comment.
Yeah, so Lance, I think Lance hit on that really well. The manufacturers have got safer surfactants now. I mean, the ones that were causing the damage were the ethyl ethoxylates back in the day, and those did interfere with ethylene. It was an ethylene effect that seemed to be causing the damage. And like anything, it depended on the environment, and the damage occurred when the crop had been stressed for a fair bit, and all of a sudden here comes a heavy rain. Crops like a coiled spring growing like madness. when it came out of that stress, and here we come and put the surfactant on, and that's when we got smacked. So it was a sort of a unique set of conditions that caused it. Now we do have safer surfactants. I wouldn't say ignore it, but if your crop is coming out of a stress and growing like you came out of a coiled spring, probably not the time to be spraying it with anything.
We had a good follow-up question. You mentioned Xyway, Dr. Below.
Yep.
Matthew had a question. He says, does Xyway control FCR, which I'm assuming is probably Fusarium crown rot? I asked to make sure that's what he was referring to. He's probably talking about the crown rot complex. So if you want to. So
I don't know the specific answer to that. I haven't looked at specific diseases controlled. It's a flutriazole, I think. I mean, obviously, it's there and active at a time when crown rot might be occurring. So I can't specifically. I don't know what the label says on that disease, Lance. I don't know if you do or not.
We have looked at it. We have not probably tested it as extensively as the manufacturer of that product has. So obviously, what I say about it doesn't trump what they say about it. In our trials, we have not seen what we would consider to be a major impact on reducing the incidence or the severity of Fusarium crown rot. But that's, in a handful of trials over a couple of years. So that doesn't answer, all the possible questions. That is the application timing that should, in theory, potentially have a benefit. My V5, V6 fungicide application that I think does help a plant ward off some crown rot infection, is an indirect benefit at best, because that V6 application is not going down into the roots where the crown rot infection is occurring. If a V5, V6 fungicide foliar application helps suppress crown rot, it's only because it's making the plant healthier, making the plant feel better, giving the plant the ability to maybe ward off, various pathogens. We are not translocating fungicide down into the roots. If it's a soil application and it's taking it up through the root, it's where it needs to be to potentially have a benefit. That being said, we haven't necessarily seen that benefit in our trials, but it's certainly something that bears looking into. And we have looked at about anything we could put in furrow with a planter to hopefully suppress crown rot. And we haven't really found anything yet that made a significant difference. So that is still an area I think we need more research, more products developed. I don't think we have really the solution to crown rot yet. Genetics is a component, foliar fungicide use is a component, the environment. Dr. Below, you've done a lot of work, and that weather and environment thing just keeps coming back as the primary driving force of everything. And diseases, yield, nitrogen, what have you, everything's influenced by the weather.
Well, it comes back to G by E, and that's the E is the environment, and that equation is what vexes us every year and makes every year interesting.
Yeah. That's we talk about that a lot. That no 2 years are the same. Everything we learn this year is interesting, fascinating, good to put it in the memory banks, but we're probably never going to have this year again. So every year we have to kind of take what we see with a grain of salt. You're mentioning G by E, that made me think of the disease triangle for some reason. And I'll put you on the spot here. What do you think of the disease square? Are you a believer in the disease square?
Okay, so now I'm really on the spot. So I want to remind you, Lance, that I'm a physiologist, not a pathologist.
That's right.
Sometimes people get these terms confused. Pathology, psychology, physiology. I mean, in reality, Lance, when I go to the doctor, I don't want to hear pathology or psychology. Those are out of the question. So I'm a physiologist, and physiologists, what they try and figure out is the why. Mm-hmm. If you think about crop production, it's what works, maybe where it works, maybe when it works, and then the physiologists try and say why it works. So this is my long answer to hopefully forget the question that about the disease square. And so maybe if you could prod me, Lance, of what the square is, I can comment on it.
Yes, you will be able to comment on this. So when I was a student here at the University of Illinois and any other university for decades and decades, you had the famous, and you seemed like you can't get through a presentation without on diseases without this disease triangle coming up. So you've got the pathogen, which is the disease. You've got the susceptible host, which we're talking about corn here. You've got the environment.
Yep.
Well, and it was always kind of implied that there needed to be some time involved for that.
That was in the middle of the triangle.
In the middle of the triangle.
Uh-huh.
I was going to say, it was a little misleading, square versus,
Well, no, they are. Literally. They're
Even physiologists know this.
They're trying to turn it into a square by making time the fourth component. And I'm a traditionalist. To me, they don't need to have a disease square. Triangle's fine. Time was always in the center of the triangle.
I would argue that the other square of the disease triangle, the other disease square, should be management. All right, because when you manage the crop, if it's healthy, sometimes it can come through diseases.
Right.
And part of that management would be selecting the right genetics, the right density, everything else. So I'm not opposed to. I know time plays a role. And by the way, it could still be in the middle of the square too.
Yeah, well, that'd be a fifth spot there.
Yeah, well, I'll say that your management can play a big role in how the disease triangle operates. So that's what I thought you were getting at.
So that I didn't intend this as a segue to get into your response to management work, but since we're talking about management, the impact that has, based on the work that you guys have done over the years with your MIP trials and other things. What do you think the biggest levers are that farmers can pull to try to increase yields?
Yeah, so if they could irrigate the crop, they could control some of the weather. And I know we don't have a lot of that option, but irrigation is management. Mm-hmm. If you look at my 7 wonder list, and we sort of rebadged that for 300 bushels. When it comes to corn. Fertility plays a huge role. Mm-hmm. It sets the trajectory for yield. Now, a lot of that fertility is nitrogen, but I don't have to tell growers that, if you don't have the other nutrients in place, then guess what? You don't use the nitrogen properly. So what I have seen is that fertility, the right balance of fertility, sets the potential for crop yield. Mm-hmm. So I don't know. I'll say it upregulates genes or somehow gives that potential. Now, of course, if I'm going to talk about fertility, I got to talk about right rate, right time, right source, and right place. That's shockingly similar to the 4 R's.
4 R's there.
And I'm a huge proponent of placement, Lance. Mm-hmm. Place the fertility where the root's going to be. Right. I mean, rather than fertilize the whole soil. That I think is something that growers could really do. I mean, I don't have to tell you how important hybrid selection is, variety selection. I mean, so, I'll tell you, if you got the right fertility and you got the right hybrid, well, you go a long way to having high yields. So those are 2 of the biggest factors that I think growers should pay attention to.
So you're talking about placement, and you've done, the vast majority of the fertility work you've done has been with banded placement. That is a practice, as you allude to, that, a lot of people don't do, more people could do. I think there's some, barriers and unwillingness in some people's minds to go there. It is more difficult, it's more expensive, slows you down, lots of things that people could use as excuses not to do banding. How do you feel that if you do go to a banded approach, is that the only thing you change in your program? You go from broadcast to band? Do you adjust your rates? Do you what else changes, I guess? Yeah,
so there's a lot of things that have to go along with it. So let me talk a little bit first before I get to that question about fertilizer placement. I mean, starter fertilizer is a version of banding. Mm-hmm. I mean, you're just not putting as much of it. When we did banding, think about people that are doing strip till, right? They're running a shank through the field. I mean, that's a sort of a no-brainer to place some of the dry fertilizer in that shank.
Mm-hmm. That's what I do at home.
Yeah, well, to me, I mean, it takes time, takes more horsepower. By the way, you could, now today with RTK and auto steer, you could band fertilizer without strip till. Mm-hmm. I mean, I'll tell you, and this is what Adam did when he was here. He actually understood equipment, and we got us a toolbar donated, and he fitted up with some row units. And I remember this distinctly. 2009, he banded some some premium MAP, and on a field that said it wouldn't work, and it was a screaming improvement in emergence and early growth. And I'm a pretty excitable guy. I was excited. I call all the retailers out. I'm like, take a look at this, and they all said to me, well, this is cool, but we can't actually do this because it would take too much time. And, we got these floaters, and they operate fairly quickly. And that was like punching me between the legs.
Mhm.
But I said, well, I'm not discouraged. I'm going to keep working on this because if the yield is big enough, somebody will figure out a way to do it commercially.
Right.
And I think we saw that abandoning that fertilizer. I mean, just roughly, it was 10 bushels better than broadcasting it.
Yeah.
And it had to do with the fact that the root doesn't occupy the entire soil area.
Right.
I mean, if you dig up a root of today's modern hybrids, by the way, most of its horizontal spread is about 7 inches. I mean, it sits in about 7 inches. So why would you fertilize the whole soil when most of the root sits in 7 inches? Seems to me like there's a lot of fertilized space in between.
Speaking of roots and intercepting fertility, talk a little bit about what your research has shown the impact of population is on root mass and the ability of a hybrid to forage for nutrients.
Yeah, I never saw this coming, Lance, until we actually measured it. And so what we've done with a lot of root digs, actually published this work, as you increase the density of plants, each individual plant has a smaller root system. So in other words, as we increase density, all of the extra biomass is above ground. So, and we actually quantified this. It's a linear decrease. For every 1,000 plant per acre increase in population, each plant has 2.5% fewer roots. So, I don't have to tell you that density is one of the factors that's increased the most over the last 50 years. And so as we increase density, and I'm a huge proponent, that's what we're going to have to do to continue to grow high yields. The plants are going to have a smaller root system. Now, how are we going to manage plant higher density with a smaller root system? Well, we're going to have to place the fertilizer where the root is. Now, I wish I could tell you it was that easy because I'm shocked at how much variation there is among commercial hybrids in their rooting. I mean, you wouldn't think so. Apparently they're not selected on rooting, they're selected on yield, but they differ quite a bit. And I have this horrible notion. I know you're not going to like this terminology, Lance, but I'm going to tell you that in general, a offensive hybrid is one that has a smaller root system, right? By the way, you pay for roots and yield. And those offensive hybrids that have the smaller root system, boy, if you manage them, they have some yield potential, but they can also root lodge if you don't. And a defensive hybrid is one that has a larger root system. In other words, it can mine the soil for nutrients. Guess which one responds better to the abandon? The offensive, and the one with the smaller root system.
Yeah.
So this is a great segue, guys, to incorporate a question that I had come in. We're talking about offensive and defensive hybrids. Gary had asked a question. He says, what's your opinion on planting corn that is rated responds well to fungicides? Okay, so meaning more of an offensive hybrid. And he says, why would you not plant only those types of products if you're a fungicide advocate?
So we've done and we continue to do work to try to identify the fungicide response based on genetics. It's been an exercise in frustration, quite honestly, because we see bigger responses based on environment than we do based on genetics. Genetics will influence it, but I haven't yet found a hybrid that won't respond to fungicide. And if the environment is conducive to a big fungicide response, even a non-responsive hybrid is probably still going to respond enough to put money in your pocket. So I don't necessarily feel that based on fungicide response is a good way to select hybrids. Now it might, I would say, select the hybrid based on yield and other attributes that are important to you and soil type and the environment that you're placing it in. And then maybe you'll look at if there is fungicide response data available, which there's not much of that out there, to be quite honest with you, to help you make that decision as a grower. Then maybe you decide, do I put this hybrid in a field that's hard to spray, that sometimes I don't spray? I've got 2 neighbors that live right next door that don't like it when I'm flying over their house, that sort of stuff. We've all got places where it's difficult to spray fungicides. And maybe you use that as a tiebreaker to help position products. I'm a pro fungicide guy. I'm putting fungicide on every hybrid I plant. The joke I've always told people, one of the things that I have liked, a question I like getting the least is, which one of your hybrids need fungicide? Well, I don't know that any in the pre-tar spot era, I used to say none of them need it, but they all like it. Now that tar spot's here, some of them need it as well. So that has changed a little bit.
Yeah.
But
I don't even argue most of them need it in tar spot.
yes, yeah.
Yeah, so I've gotten that question too, Lance, and I think you answered that fairly well, actually. I mean, most hybrids will respond to fungicide, some a little bit more than others. We screen hybrid response to fungicide every year as well, and it's really hard to characterize them, as you said, as responsive or non-responsive. What we tend to see is when you have the highest yield potential to protect, oh boy, that's the time that you respond to the fungicide. So if it's a hybrid that produces a high yield potential, then it's probably going to respond pretty well to fungicide.
Even in the absence of disease.
Even
right?
in the absence of disease. Or if it's an environment that is conducive to high yield, which is also generally conducive to the disease, then it's going to respond to the fungicide. Now, there's a clear variation. I mean, in our management yield reports, we always look at the response to fungicide. And in general, I'll make the loose statement that hybrids that I would characterize as offensive, which generally respond to management, generally are slightly bigger response if than a what I will call a true defensive hybrid. But they all like it.
And if it's a hybrid that you would consider to be more offensive, it may have a few more agronomic weaknesses from a plant health standpoint that it might like that protection a little more too.
That's probably right.
Okay, good questions. More?
We've got plenty more.
All right. Well, we need to focus on questions and not on what we're talking about.
Well, but the questions are going right along with Dr. Bealo's management strategy, which we're all very familiar with, and all the different components of it. So
I'm noticing a difference here, Adam. When it's me and you doing this, we've never been inundated with questions, and we can't keep up with them. So thank you, Dr. Bealo, for
this is stump the professor time, right?
Well, yeah,
I mean,
yeah.
We a little nervous here.
We thought about calling this "Stump the Agronomist" instead of "Ask the Agronomist."
That'll be fairly easy to do.
So we've got some. I'm gonna try to put these together and let you guys roll with it because we've got some congruency here going on. When you guys started to talk about banding in your fertility programs and management strategies, we've got some questions from Bruce and we've got some questions from Gordon as well regarding biologicals, and also one about humic products in that fertility zone you're talking about.
I'll let you wade into those waters.
So let me roll them to you just a little bit here. So Bruce wanted to know, Dr. Bealo, what role do you see in biologicals, or what role do you see biologicals playing in the next few years, increasing yields and moving forward in the next few years? And then as you're talking about the biologicals, Gordon had a question about who or what agency controls the biologicals in regards to labeling. So I'll let you work on that one a little bit, and I'll bring up the humic product question.
Yeah, those are good questions, and two different questions. Let me touch on the regulatory one first. So when I say biological, I use that as an overall category to include the plant growth regulators, the living microbes, and the biostimulants. Now, plant growth regulators, those are your auxins, your gibberellins, your cytokinins, and I'll say the regulation isn't quite set yet, but usually the U.S. follows what European Union does, and in the European Union, plant growth regulators have to be registered now as pesticides. Now, there are some that have been on the market that are kind of going to be grandfathered in, not have to go through the regulation, but in reality, a true plant growth regulator, this is one of the classic plant hormones. Those should be in the future regulated as pesticides. Now, the living microbes and the biostimulants, the regulation hasn't been quite worked yet. Most of those are sold as fertilizers. Notice, I buy a humic acid product. It's a liquid humic acid. It's got 0.5% potassium in it. It's a fertilizer. I mean, hard for me to imagine what that little bit of potassium is doing. But so a lot of these are registered now as fertilizers or I think in the future, the goal is going to be to register them for what they're supposed to do, not necessarily what's in it. So stay tuned for this. This is still a work in progress on the registration. I forgot your other question. It had something to do with biologicals.
So I believe it was Bruce was wanting to know more about what you think the future of biologicals will be in playing into the management.
Okay, thank you. I don't have to tell you that this area has exploded, and everybody and their brother has a biological product now that do a whole host of things.
My brother's one's better than your brother's.
Oh, no doubt about it. And so I look at the research we've done in our lab over the last 5 years, and the number of biological trials has increased almost exponentially. So I think they're here to stay. I think they have potential. Okay. We just talked about how as we increase the density, we have a smaller root system. I think increase in density is a key yield component. It's not going to go away, despite the seed cost. Mm-hmm. So we're going to continue to have to grow more and more plants. We're going to have a smaller root. Here's one of my theories. Mineral nutrients and water enter the plant through the root. Pretty sure I can prove that. Mm-hmm. And if we have a smaller root system as we plant more plants, guess what now? They're going to be more under water stress under some situations. They're going to be more challenged to acquire those nutrients. Here's where I hope the biologicals come in. All right, if I got a biological product that can help relieve a little stress, yes, maybe I can get by with a smaller root system. If that biological product solubilizes phosphorus out of the soil or increases the root system, the area of the root system, and helps the plant acquire nutrients, then I think it has a real value. So I think the problem is a lot of unsubstantiated claims on biologicals, but I'm fairly optimistic person, and I know some of these are going to help. And I'm gonna blame Bayer as being a big player in this biological market, because I'm pretty sure I can't buy a DEKALB seed that doesn't have a biological already on the seed treatment.
There's a phosphorus solubilizer.
Yes. I think it's penicillin Belli, right? Yeah. BioRise.
Yeah.
I mean, so you guys are kind of started this.
Well,
it used to be BioAg, I think it was called.
There was a little product called Votivo that came out a lot of years ago that was in that space. So yeah, we're all in that space, and it is a frequent question I get from growers. I mean, you know growers, they like to try things, they like to push for higher yields. They're willing to invest in things that will improve their yield, but there is just a lot of questions around all the numerous products that are out there. And you mentioned some of the claims that are made or might be stretching it just a tad, and guys just wonder, how do I pick? There's hundreds of them.
Yes.
And I can't buy them all. And how in the world am I supposed to know which one I should believe in?
So I will tell you, this is the time for me to pitch our website. We try and put some of our studies on our website, Crop Physiology Laboratory. You have to be able to spell physiology, but
or just click the link that I put in the chat.
And this report is not on the website yet, but it will be Monday. And this is our Illinois biological testing report. So we evaluated 11 different products on corn, and we have a soybean one too. We evaluated 8 products. And what the companies had to do here is they had to bare their underbelly and let us name their product by name and compare it to all the other products. Mm-hmm. And a lot of them run away screaming when you give them that option. But
that explains why there's only 11.
There was a few brave ones that actually did it. And what we do in this report is we honestly try to position the biologicals for the greatest success. So we use the DEKALB hybrid. We have a Golden Harvest hybrid. We're pretty sure these aren't related because you guys don't play together very nicely.
Two different pools there.
We evaluated them with standard management, and then we used a progressive management system. The progressive being an extra side dress of N with a fungicide, and we put a paired control right next to every plot. I mean, I don't have to tell you the biological response varies spatially across the field in an ugly way. So we position these things as best as we can. I mean, for success. And then, of course, we're stuck with the weather that we got in 2022.
Mhm.
But we want to be able to bring growers unbiased third-party data. You could never prove a biological doesn't work.
Mhm.
All you can prove is those situations, those management situations, is where it might be effective.
And I certainly don't want to turn Ask the Agronomist into a stats class, but a thing I like to point out to growers is when you're looking at a 280 or 290 or 300 bushel yield, and you're trying to prove that something has a 4 or 5 bushel benefit, and there is 20 or 30 bushel of in-field variability easily, it's really difficult to prove statistically that anything you see when you're looking for such a small difference is real. And so, sometimes we take things on faith based on the science behind the product and based on the potential benefit that it should have. But it's going to be really difficult in any sort of on-farm trial to ever, if you do something on farm in a side-by-side and it's 10 bushel better, you're probably a believer for life. If you do something in an on-farm side-by-side and it's 10 bushel less, you're probably thinking somebody's selling you something that doesn't have value. And you can plant the same hybrid next to itself 10 times in a field and get 10 different yield numbers on those passes through the field. So it's difficult to evaluate the products. I'm glad Dr. Belo and other researchers are looking at these things. And so there is a third-party source of information. You don't just have to believe everything the manufacturer tells you about these products. But I would say, talk to people that you trust, that have had experience with products, and try to choose wisely. I think this area is, there's a lot of good products out there. There's a lot of products making claims, and we've got a lot to learn about that whole biological space.
Yeah, I want to chime in on this, Lance. Boy, when it comes to evaluating biologicals, statistics is the bane of our existence. I mean, good luck. There's no way you'll statistically, without a lot of replication and a lot of pairing, show a 7 or 8 bushel response is statistically significant. But here's the thing: since most of these biologicals are getting a free ride along with some other application pass, if I put it on the seed, or I put it in furrow, I put it with a post-emergent fungicide, or I put it with the post-emergent herbicide or the fungicide. If I'm already making that pass and I put that biological in and I get 7 bushels as a free ride, and it doesn't take much money to pay for it.
Right.
So the reason you don't see a lot of peer-reviewed studies on biologicals, the success of biologicals, is their response is usually too small to prove statistically.
There's also something that's interesting in the space. I think it's kind of you talk about physiology. Well, this gets more into psychology. There's a price point at which growers will try things. And so I see a lot of things that guys are throwing in because they're $5 or $6 or $7 an acre, and corn's $6.50 a bushel. And you're thinking, well, I only need a bushel to pay for that. And they say it's going to give me 5. Even if it gives me 2, that's a 2-to-1 ROI. I'll do that. So there could be a product that is amazing that costs $20 that you won't use. And there's a product that that's $5 and you'll use that all day long. So there's kind of a price psychology that people play around with. And if it's a few dollars an acre, yeah, sure, I'll try that. And if it's $20 an acre, well, then there better be some proof behind those claims to get me to invest that much money.
Yeah, and I would encourage growers to ask themselves a question. All right, so a lot of growers say to me, I used a biological. And then I say, well, what is the biological supposed to be doing? Well, I don't know, it's a biological. That's probably the wrong approach. So what they should do is they should very specifically ask the salesperson, what is this product supposed to be doing? And then they should think, do I actually need that done on my farm? That's the basic level of before you use.
Right.
Do I need this? Am I having a problem? If I'm trying to sell you a phosphate solubilizing bacteria and you got a screaming high salt phosphate test, ask the question, do I actually need this done? And I think that'll help, at least weed out some of the some of it.
And if you want to be really challenging to those people trying to sell you something, after you ask them, what does it do? And if they do a reasonably good job of explaining that, ask them, how is that going to benefit my plant? How is that going to get me more yield? And that might help you determine whether you ought to be trying that product. So more questions, Adam?
Absolutely, yes.
Awesome.
So we've talked a lot about the root zone and trying to increase the efficiency of that root zone. And John, I believe it was, I'm getting too many questions coming in, so I got to scroll back up.
So I will interrupt just very briefly. If you ask a question, Jennifer, this is kind of directed at you. If you ask a question, whether we answer it or not, make sure they get entered in the drawing, please. Okay.
So John had a good question about humic products, humic acid products in that band, and if that humic acid product combined with fertilizer in particular will help mitigate some of the salt load, the concentration of the salt, and maybe some of the toxicities that could come along with that procedure. Will humic acid or humic products help with that?
I'll take a stab at that one. So I'm gonna put humic acid into the biostimulant category. It's one of our categories of biostimulants, and when it comes to humic acids, fulvic acids would fall into the same category. I mean, there's humic acids, there's fulvic acids. They can be liquid, they can be dry, they can be mined as leonardite, they can be sulfonates that come out of paper milling processes. So, I don't have to tell you, they differ. And everybody has either a better mine or a better extraction or a better heat. And so they're all different, but there's two major physiological roles of humic acids. They're highly negatively charged. I mean, in a way, you could say humic acid is sort of like the active ingredient of organic matter. Mm-hmm. I mean, who doesn't love organic matter, right? That's the good stuff of the soil. And so they're highly negatively charged. And as a result of their high negative charge, they chelate cations. And so sometimes they can make nutrients, cations, particularly cation micronutrients, more available because they chelate them, prevent them from being complex with phosphates or sulfur. So they can act as chelators, and they can, in some cases, make certain mineral nutrients available. They are also carbon sources. So if you look at them, not only are they highly negatively charged, but they got a lot of carbon to them. And so what they really also represent is a food source for soil microbes. I mean, they're a recalcitrant food source, so it takes a while for the microbes to chew them up. But they have an immediate effect as a chelator, and then they sort of act as a long-term food source for maybe supporting the microbiome, some of the activity in the microorganisms. They're one of the categories that we're looking at, and they're probably the oldest of the biostimulant category. Been around a long time. I generally don't see a downside of putting them in furrow. When I do see it, it tends to be positive.
So I guess one follow-up question I'll ask, and this is something I get asked from growers all the time. There's always the temptation of, if I'm going to use a product that improves fertilizer availability or improves fertilizer efficiency, and I'm going to invest in that product, can I reduce my rate of fertilizer that I use to offset that cost, or should it be additive?
Yeah, usually what I see is it's additive. It's not a reduction, because what it usually does is it keeps the root system or the plant healthy, and then the plant can actually respond to those extra nutrients that are available. So I wouldn't say to replace my fertilizer program with the humic acid or the biological, but I would say that sometimes those biologicals help improve the uptake efficiency of the fertilizer you've already applied.
I got a follow-up question to go along with this conversation. I know that you guys, or you've done some research with Pivot Bio in the past, and I've got a person, Cody, that would like to know a little bit more about what your synopsis or thoughts are on Pivot Bio, generally speaking.
Yep. So Pivot Bio, and let me Proven 40, and what it is it's a engineered microbe, actually a mixture of two microbes that colonize on the root system. They live off the exudates by roots, and then in return, they supply some nitrogen out of the air to the root system. So we're all very familiar with this process in soybean.
Mhm.
You know, we know the soybean nodule has the bradyrhizobia. The soybean plant gives the bacteroids in that nodule sugars, and in return, they take some of the air out of the atmosphere. So this association with proven 40 on cereal roots does the same thing. It provides some N to the plant. Now, I view it as another source of N. So think about where the corn plant gets its nitrogen from. The corn plant gets its nitrogen from the fertilizer and the soil. And it's about 50-50. And I don't think growers realize how much nitrogen their soil, the mineralization of their soil also supplies. So if the corn plant gets half its in from the fertilizer and half its in from the soil, and then we're looking at huge spatial variation across the field, I'll guarantee you every grower has some parts of every field where either the soil lets them down by not mineralizing as much, or the fertilizer lets them down by being lost or not available. And the N-fixing bacteria now is another source in those areas, a third source. So I view it as a way to even out the variation that it's going to occur across the field. Maybe it's a replacement for some insurance nitrogen. We've done a fair amount of research with it, and we have seen that it does supply extra N. We've done this by measuring the plant, by varying the rate of N, by looking at 15N, and some of the N is in fact coming from the air. Now, are we going to replace synthetic fertilizer completely? I'm a little skeptical now. But is it going to be another source of N to, I don't have to tell growers how important N is when it comes to corn yield. Is it going to act like another source? And is it going to be valuable in certain areas of the field? I think the answer is yes.
Yeah. Excellent thoughts on that. I appreciate, there's a lot of questions actually about the bio come up. So thanks for that. We've got some things we need to circle back around, fungicide application related questions. One more though that popped up real quickly when we're talking about biologicals. Would side dressing anhydrous ammonia in season have a negative effect on your biological activity?
So I mean, that's one of those things that your soil biology purists tend to hate anhydrous. Some of them hate glyphosate as well. There's lots of people that like to hate lots of things. Anhydrous ammonia is certainly a toxic thing, but corn likes nitrogen, and corn can benefit from side dress nitrogen. And some of the highest corn yields I've seen produced this year happen to be produced with side dress, anhydrous. So it's not a common practice in our part of the world, mainly just due to it's not the easiest way to side dress nitrogen. So I can't say that based on grower results, I've seen any evidence to say that we are hurting our yield potential by side dressing anhydrous. Could you measure some negative impact to the biology in the soil? Probably in that band, you probably could. Whether or not that has the potential to, the soil is a strongly buffered system. It can, come back from lots and lots of things that happen to it: flooding, drought, salty fertilizers, toxic fertilizers. So I don't know that there's anything, philosophically wrong with applying nitrogen that way, if that's the way you want to do it. I've always believed that the corn plant really doesn't care what form of nitrogen you give it. It just wants it when it wants it. And whether it's coming from urea, UAN, anhydrous, ammonium sulfate, there have been people that have said, well, a crop would like to have this ratio of ammonium to nitrate, and maybe in a controlled laboratory environment, maybe there is a ratio that the plant would like, but you can't really control that out in the real world. So I don't know. I'm kind of stumbling around in the dark there. I'll turn it over to Dr. Belo.
Yeah, so I think a lot of people have the misconception that fertilizers somehow hurt the health of the soil. They hurt the activity of microorganisms. Now, no doubt, if I side dress anhydrous or if I put it on in the fall, regardless, there's going to be a temporary effect. I mean, the sterilizing effect in the area where that anhydrous is.
Take a good snort of that stuff. It's hard on you.
But not only does the corn plant like nitrogen, but so does the microbe. I mean, microbes need N as well. And when we measure microbial activity, we actually see it's higher when we fertilize the soil because the microbes use the fertilizer as well. So when it comes to anhydrous, it's a very effective source because it's the highest percentage N of any fertilizer. We're not hauling around a lot of other weight. It's usually one of the most cost-effective fertilizers. So when it comes down to the timing of N with a side dress, it works very well. And I don't think, I'm not worried about the temporary impact that it has on the soil biology.
Great. Thank you for addressing those. So circling back to fungicides, we're talking about timing and nitrogen, and we're trying to get better and better about making everything we do from a management standpoint more efficient. So this is a question in regard to fungicides and the efficiency of timing of day for that fungicide application. Is there anything you guys have noticed or anything that you can add to whether or not the time of day has an impact on efficiency of your fungicide application?
So I would say the short problematic answer to that question is yes. I don't have data specific to that, but if you just look at how the plant varies throughout the day and how temperature, moisture, humidity, sunlight impact the ability of plants to uptake whatever you put on them. We've seen this with herbicides. We've seen that there are times of day when the plant's under stress that you're not going to get as much herbicide into the plant, translocated through the plant. Sometimes that can impact efficacy. I don't know of any reason why fungicides would be any different. Practically speaking, I consider this to be a non-starter conversation because unless you've got your own machine and you are doing your own application, your ability to dictate time of day of application of fungicide is zippo on your farm. So I try to avoid the whole topic, to be quite frank with you, because all it's going to do is make an already impossible job of getting fungicides on timely and appropriately that much more difficult. So I don't want to tell anybody to be the guy that is a huge pain in you know what for somebody, because you're the guy that says mine has to be done in this period of time here and make everybody else wait because mine has to be perfect. There are too many variables out there. Sometimes we get a 30 bushel response to fungicide. Sometimes it's 3. I don't think that humidity, leaf moisture, and temperature explain all those differences. So in a theoretical, answer to your question, does it matter? Yeah, it probably does. Practically speaking, I don't know how anybody's going to manage that.
Yeah, I think Lance hit that pretty well. My guess is that any time is better than not at all. I'm sure that if you and this is not an easy thing to study. Weather conditions impact on the success of fungicide application. I'm pretty sure I don't want to apply it in the rain. That would be my number one recommendation. But it's a very hard question to answer and probably something I wouldn't lose any sleep over.
So when we're out there making our fungicide applications, regardless of time of day, Alan wants to know what your thoughts are on always adding insecticides, whether you're talking application of fungicides on corn or soybean.
Okay.
Wants to know.
I'm letting you go first.
The industry guy will take this one first, and then we'll let the academic guy chime in. So I think if you're looking simply at ROI, efficacy, yield, chances for something positive happening in your field, especially on soybeans, it is undeniable that the presence of an insecticide with your fungicide is going to increase your odds of getting a positive response. I believe that so firmly that I tend to discount research that's done on fungicides without insecticide in the tank because that's just not the way it's done in the real world most of the time. It's less common in corn, although as you go to Northern Illinois, where corn rootworm has been a huge issue, and there is an entrance in getting some adult beetle control, insecticide hitching the ride with fungicides and corn applications is getting more common, and there can be benefits to that. From an integrated pest management standpoint, it's a hard recommendation to make because we are almost never at threshold for any particular insect when we do that. Yet we tend to see this yield benefit. And so that puts us who try to be responsible agronomists in a bit of a tight spot making that recommendation. And that's what Dr. Bilo and I were kind of joking about a little bit when the question came in. So, you know, I think we need to be judicious in how we use products. You know, if something is harmful or dangerous, we shouldn't be using it just to get an extra couple bushels of yield. But if applied properly, these products are safe. I don't see any issue with using them. And I do think, especially in soybean, there are probably times we should use more insecticide than we do. I think with the stink bug pressure that we have and later generation being leaf beetle feeding, and I've always felt there's probably some soybean acres that would have benefited from an additional insecticide application even after our R3 fungicide due to some of these late feeding insects. And as we look at things like Japanese beetles in corn rootworm beetles in corn, other insect pests. Now, the flip side of this is I have actually seen situations where I think including an insecticide at VT actually increase corn leaf aphid populations later in the season by possibly killing off a few beneficial insects that might have been helping keep those aphid populations down. So that is one of the arguments that people that argue against just throwing it in for the heck of it will say could be a concern. So I think there are situations where we would probably benefit from more use of insecticide. There certainly are drawbacks to doing that from a IPM standpoint, perceptions of environmental stewardship standpoint, and there could actually be situations where you could inadvertently make another pest worse, maybe by including an application that you didn't absolutely have to do. So, Dr. Bilo, any thoughts?
Yeah, so I agree with almost everything Lance said. You know, when it comes to the economics of the application and the additional cost of the insecticide, well, it's almost always going to pay, is what I've noticed. Now, when you look at the research we do, you know, if you look at our corn or soybean management reports, we don't call it fungicide, we call it foliar protection because we always include the insecticide. Largely because, you know, if you're making that pass, you might as well. And we spent a fair amount of time in soybean researching this. We looked at insecticide, fungicide, and both. And in soybean, it's an example of 1 + 1 = 3 when you mix them together. I mean, how many times do you look at your soybean? Looks like I took shotgun to it. So I think insect feeding is as big a problem as disease. In corn, you know, I mean, market it however you want. Pollination aid, I don't know what you're going to call it, but we mix them all together now. I mean, that's just the way it's done because when we're making a foliar application, we're trying to protect the activity of that foliage. And so it's foliar protection, and we're protecting it from both diseases and insects. I've seen the aphid problem that Lance described, and I don't believe it's from killing the beneficials. What I think happens many times when I put that fungicide application on, guess what? The plant's healthier. It stays greener. It's got more sugar in the stalk. And that's what attracts the aphids, not necessarily the lack of the aphid lions or whatever else I killed. You know, anytime I got a healthy plant, it's going to have more sugar in it, and that's going to attract the aphids.
Yeah, great questions. Thank you very much for that. I have had another question come in. As you guys have been discussing the interaction of population and what plant densities do for not only the yield component aspect and increasing yields, but the correlation between root mass and above ground biomass, how that works into a more intensive system in the future, knowing that short corn is on its way.
That sounds like a question from a bear person.
It's a very well-trained grower.
So I know Dr. Belo's been very involved with us with work on short corn. And a couple of years ago, we wouldn't let you talk about that, which I know frustrated the hell out of you.
Terrible.
Yeah. And I think we've gotten over that now. And since we're getting close to ready to sell it, so I think we've kind of unmuzzled, which an unmuzzled Belo is a dangerous thing. But we've unmuzzled Dr. Belo, and I'll let him talk about his thoughts on the short corn system and what they've looked at.
So I'll talk about short corn first, and if I don't hit on the exact points of the question, Bob, please reiterate. But short corn is designed to tolerate wind damage. I mean, now we're having more and more wind damage. We've learned this new term, derecho, which apparently pretty damaging, and I've seen a lot of wind damage. And if you look at short corn, I have to tell you, I'm a huge proponent of it. I'm not standing up, but I'm kind of a short guy myself. So, I like the idea that good things can come in short packages. But there's some serious physiological advantages of short corn. If you look at short corn, what it does is right out of the ground, I can't tell it's short corn. If I'm looking at it, what it does is it stacks those internodes right below the ear. So 2 or 3 internodes right below the ear become compressed. And guess what? It appears that energy that would have gone into growing those stalk internodes at exactly the right time, where does that energy go? It goes to the ear shoot and the root. And so we actually see a little bit better rooting profile in the short corn than we do in the tall corn. And I think what it is, it's a redistribution of energy. Instead of expanding those stalk internodes that are right below the ear, now that little bit of extra energy goes to the root and the ear shoot, and those can have some, pretty serious advantages. Now, short corn, when you increase the density, does decrease its root size, just like any plant. But since it has a slightly different partitioning at the exact right time in the first place, in our research, we've seen it can tolerate a higher density. Also, it's got that, if you ever look at a short corn plant, boy, the bottom of the stem is a lot thicker. So that helps it withstand that wind, and it also helps it stand up, have better standability in the first place.
Yeah, I would say the first time I heard us start to talk about more root growth, I was actually nervous because I'm used to roots robbing energy from a plant.
Oh yeah, definitely.
And plants that grow more roots than they need tend to yield poorly. There was some interesting work done years and years ago by entomologists here at the U of I, looking at the ability of hybrids to regenerate roots, and some hybrids regenerated roots after rootworm feeding better than others. And the thinking was that maybe we should select for, this was back before traits, when all we had were insecticides that sometimes worked, sometimes didn't, to control rootworm. Thinking was, well, maybe should we be looking for hybrids with the ability to regenerate roots better as a way to manage rootworm? Well, they found there was a strong correlation between the ability to regenerate roots and the ability to generate yield, and they were inversely correlated. But the nice thing about, and Dr. Belo touched on it, the timing of when the extra resources are available that are probably driving some of that additional root growth isn't robbing anything from yield. And it's different than a corn plant regrowing roots in July when it's got better things to do. So we're actually seeing a potential yield benefit from having this bigger root system, as opposed to it maybe being a detriment because it was robbing resources away from the ear.
Yeah, you guys hit the nail on the head. I think that's what he was interested in, is the interaction between increasing plant densities and what that might affect with our root mass.
And I'll add, our product concept with short corn is not to tell you all that you need to radically increase your population overnight when you switch to short corn. Our product concept is to deliver a short corn product that if you manage it the same way you've been managing the corn you plant today, you will achieve the same yield. I do think that short corn offers you the ability to, with better peace of mind, start to push for more. Our data would say, and I think Dr. Belo's data would back this up, we are underpopulating corn today currently versus what would maximize yield. But most of you are uncomfortable pushing higher with what you're planting today because of fears of standability, lodging, harvestability, those sort of things. So I do think that short corn will be a great enabler to enable you to have the confidence to try planting a higher population. And that's probably how we're going to chase more yield. If you're thinking about narrow rows, we're also not necessarily going to promote short corn as it has to be in a narrow row system. But I know Dr. Bilo has always been a believer that, as we push yields higher, as we push populations higher, as we crowd plants closer together in the row, it's kind of intuitive that we could use a narrower row system to give better distribution of those plants across the acre. And I think short corn will lend itself incredibly well to narrow row systems as well, if you so choose to go there. There's not going to be a requirement to do that, but I do think it will enable higher populations, will enable narrow rows, and that's how we think that we're going to achieve greater yields long term with this system, because you're going to be able to push that plant harder because of the improved lodging.
Yeah, of course, if you give an academic like me something like short corn, I'm going to push it to the limit. I'm going to want to know, what densities, what row spacings, these are the kind of things I want to look at. So I want to remind growers that yield is a product function of how many plants you have, how many kernels are on each plant, and the weight of each individual kernel. And any one of those can impact yield. So it's how many plants, how many kernels per plant, what the weight of each individual kernel is. And you got to increase at least one of those to have an increase in yield. Now, sitting here today, which one do you have the most control over? Well, it's the number of plants. I mean, yeah, you actually have to buy the seed off of these guys, but that's the yield component under your control that has the biggest impact on corn yield. Think of each plant as like a solar cell, right? They're collecting light, and if you got more of them, well, now I close the canopy quicker. This is why populations have gone up. This is why I'm so excited about trying to manage a higher population of plants, because it's the yield component under your control that has the biggest impact on yield. And it's the one I think a lot of us do underpopulate. I think it has something to do with your expensive seed and worry about the weather, and how am I going to manage it. That's the component that's has to change, continue to change.
So since that component is the thing under our control the most at this point in time, especially, tell me a little bit about the research you've done with narrow row spacings, and if you think that is something that we can currently benefit with our management strategies that we have available to us today in this part of the world and kind of the central Illinois area, or whether that is something that we need to continue to work on management and genetics to get the advantage out of those narrow row spacings. I get a lot of questions about 20-inch rows. Should we go to 20-inch rows? What's the opportunity there?
So I think Adam knows I'm a huge proponent of narrow rows, because when he was here, we put a big investment into the equipment that will allow us to plant and harvest narrow rows in order to do that. And to us, a narrow row is a 20-inch row. But by the way, a 15-inch row is also a narrow row. I mean, we operate 4-row equipment, and we can side shift that equipment, the toolbar on that equipment, to not be in a tire track. So we cannot with our 4-row equipment research a 15. So we look at 20s. And quite simply, if you think about this, I mean, if you were to take the same population and put it in 20-inch rows versus 30-inch rows, you're going to cover the ground with more green. You're going to intercept more early light. I mean, it's an absolute no-brainer. And I'm pretty sure our whole goal is to intercept light, right? That's the whole premise of ag. So I'm a huge proponent of narrow rows for one, increase my early light interception, and I can increase the distance between plants. I mean, so that I don't have as much inter-row competition. Now, when I was a student, and this was well before Lance, right? I mean, I learned that narrow rows only worked in the northern part of the Corn Belt, north of I-90, where we had a long day but a short season. I learned if you were south of I-80, it wasn't going to work. And if you were south of I-70, forget it. You don't need the narrow row because you have a long enough season. Well, it turns out that's completely wrong, all right, because we weren't planting the densities we're planting today. Here's the reason that we see narrow rows work everywhere. all right? And it has to do with the size of each plant's root system. At every density, if you compare a 20-inch row to a 30-inch row, the size of each plant's root system is 20 to 25% bigger. Roots don't like to grow into each other. They grow in the open area. And when I have a narrow row, I got more space between the plants. I get a bigger root system. I mean, if you look at the effective density, putting it in a 20-inch row is like gaining the root system size of 6,000 more plants in a 30-inch row. Now, what do you think happens in southern Illinois? We're water stressed, and if I have a plant that has a little bit bigger root system, now it can achieve more water. So we actually see almost the same benefit of narrow rows in southern Illinois as we do in northern Illinois. Now, I know growers are thinking, what's the benefit that you get of narrow rows? Again, this is on our website. It's our corn management report. This one's actually on there right now. You could look at the value of narrow rows to 20-inch rows to 30-inch rows. This year in Nashville, it was 7.5 bushels to 20-inch rows, 15 bushels in Champaign, 16 bushels in Yorkville. And that's pretty much what I see consistently, 12 to 15 bushel increase in yield. And it simply has to do with intercepting more light.
Is that relevant for all yield levels? We have a lot of variability out there in operations and fields, as you well know. Do you feel like that is something that we can benefit on as much on maybe some of the lower yield potential fields as well as the higher yield potential fields?
So that's an excellent question, Adam. Is it responsive on all yield levels? We tend to look at our research on the high yield levels, and then we know narrow on the rows and helping us manage a higher density of plants would help. But my guess is there's advantages of the narrow row spacing under lower yield levels, largely because of that change in the rooting pattern.
I mean, a few growers that I work with that have switched to 20-inch rows, they almost feel they're seeing a bigger benefit from it on their tougher acres than they are on their great ground. Now, your research has shown clearly that at very high yield levels, there's still a benefit to narrow rows. So it should be benefiting them on their best ground too, but it just within their operation, their perception would be that they think they've gained more on their tougher acres by making that switch than they have on their best acres.
Yeah.
But opinions do vary on that, and there is quite a barrier to entry into narrow rows, and it's I think when we first started working with short corn, and I think other people that have had short corn products in the marketplace have tried to tie it to a narrow row system, and you lose a lot of your audience there because nobody wants to be forced to switch to a narrow row system. It needs to be a voluntary decision because it does impact tires, equipment, everything in your operation. And it is and you've done a lot of work, Dr. Belo, showing that, a systems approach to lots of things. You switch one thing and mess up 2 or 3 other things, you might go backwards because of that switch. So you got to have the whole system in place. And that's a challenge for 20-inch rows because you got to change lots of stuff. But there are benefits to it.
It is true, and I'm gonna say that most of the hybrids on the market now are not selected for narrow rows. They're selected in 30-inch rows. Right. So if you are in narrow rows, boy, the hybrid you select makes a big difference. Not all of them like it. As a rough rule of thumb, you want one that has narrow upright leaves. You take something with a wide floppy leaf and put it in a narrow row, it's probably going to be unhappy, would be my guess. So if currently a lot of the hybrids on the market, they were not selected for narrow rows. Mm-hmm. Whether they like it is just an accident. I believe that will change slowly in the future. And I think short corn is one of the things that'll help that change.
Mm-hmm. Yeah. So excellent conversation. We got one more question here before we start to wrap up. We've been having a lot of yield component conversation today, particularly around plant density, right? Number of plants. But that's in regards to corn and pushing plant densities. Mm-hmm. We've got a question that is around soybean.
Nice. Yeah.
And finally,
that shows you the proportionate level of care between corn and soybeans
Yeah,
here. It took us,
don't we rotate corn with that crop?
I was actually going to bring up beans before we quit here, just so that we didn't forget to talk about soybeans. But thank you to someone for asking a soybean related question. As a small grower, I actually enjoy soybeans. They're just, I get more work done when I'm harvesting.
They're easier to walk through.
They're easier to do. Yeah. So anyway.
So the question is around the same yield component, plants, number of plants, right? And there's a little bit different dynamic with soybeans, right, compared to corn. And his question is around how low can we go with that yield component?
Okay, so big subject there that we could dive into.
And this is a seed guy
of why soybeans respond differently to management. They're a very different plant. They determine their yield differently. They determine it at different times of the year. And there's, I think as a general rule, farmers tend to think they understand corn better than they understand beans, and they consider beans to be a mystery and confusing, and sometimes they're great, sometimes they're disappointing. I would argue that corn is sometimes great, sometimes disappointing as well, but it seems like we think we understand it, why corn's disappointing, and we like to say that, well, the beans just should have been better, and I don't know why they weren't. And so we have this attitude, I guess, that we hold soybeans to a higher standard in some ways than corn. But certainly we recognize that soybeans can yield across a wide range of populations. I'll tell a quick joke that one of our researchers used to tell, that worked at one of our research farms and did seeding rate studies in soybeans on a yearly basis. And he'd look at different varieties, different maturities, different seeding rates, always on a very highly productive soil. And he would kind of set this up, and he'd kind of bring you in, and he would say, we've looked at this for years, and he says, write this down. You'll for sure want to keep track of this. Year in and year out, the optimum seeding rate in soybeans is somewhere between 80 and 160,000 plants per acre. It's completely worthless information to you, right? Because it's such a huge range. We can go, I've seen 85 bushel soybeans at seeding rates of 40,000. We've seen very thin soybean stands. Sometimes that field you almost replanted ends up being your best bean. We could absolutely reduce seeding rates further than we have. Every year, there are lots of fields that get replanted that probably shouldn't have been. As an agronomist, when I'm walking in your fields trying to convince you that this 75,000 final stand is plenty of beans and you don't need to replant it, I often hear something like this. Listen, if I wanted to look at 70,000, I wouldn't have planted 150 in the first place. So you guys have what you like to look at, and thin beans early, they grow slower, they look worse. It just doesn't look quite as visually appealing as a nice, thick, robust stand of beans that are pushing each other, growing faster because they're competing with each other. But I would say on productive Illinois soils, 90, 100, 110,000 for a final stand is more than enough beans. And whatever you feel you need to drop to achieve that population is what you ought to drop. I'm not a believer in overseeding for insurance purposes, or assuring yourself of a good stand, because what I see is if weather conditions are such that we have poor emergence, we don't lose 10 or 20% of our stand. We lose 40, 50, 60% of our stand. And for you to achieve an acceptable stand, you'd have to be planting double what you need if you're doing it for insurance purposes. So I don't think it makes sense to overplant by 20 or 30,000 as an insurance against poor emergence, because if you have poor conditions for emergence, you're probably going to end up replanting anyway. So you were just wasting money on that seed. So I would rather see you invest in good genetics and a good seed treatment rather than more beans per acre. And I think we probably can lower seeding rates in soybeans, especially on our most productive soils. So I would say soybeans are kind of the opposite of corn.
Definitely.
We need to push corn harder on our productive soils. Soybeans, we can pull back seeding rates on our productive soils And I'll let Dr. Belo talk about what he's seen in his research.
Yeah, that's definitely what we've seen as well. Lance hit on this fairly well. The soybean plant, the damn thing branches, and then it's got multiple nodes that can have pods, and guess what? More than one pod at a node, so it's really hard to figure out. I would tell you the sweet spot's in 110,000. We plant 140,000 because we get our seed free from Lance, but I'll make a general rule that we have noticed: if you're going to plant early, and you should be planting soybean earlier, you can get by with a little less. If you're going to plant late, like you're planting in June, you probably don't want to have 70,000 plants. You probably want to have more to close that canopy as quick as you can. The soybean has enormous potential to fill in the gaps. I mean, it isn't like corn at all. I mean, it's just a completely different beast. And, we've seen the trend to cutting back a little bit. I wouldn't tell you to go out and plant 80. Generally, that's a potential failure. But 160 is probably on the high side.
Mm-hmm. Yeah, I mean, we put 140 in a bag. 140 is a fairly standard seeding rate these days. The math works good, bag to the acre.
Makes it easy.
So that's not a bad, ballpark way to be. We do have, sometimes make recommendations on varieties that don't stand as well to reduce the seeding rate a little bit. I would say, in complete honesty, cutting your seeding rate back 5 or 10,000 isn't going to do much to make a lodging-prone bean stand better. You have to radically reduce the population to improve the standability. So if standability is a concern and you're trying to manage standability with population, it takes a bigger variation than 5 or 10,000 to make much of a difference.
So I know we're running out of time, and we wasted most of our time talking about corn. Well, not wasted, but I'll tell growers, once again, a big question we get is, how early can we plant our soybean? And if we plant it early, do we manage it differently? Also on our website is our planting date study. So there's, we've taken 16 soybean varieties, 8 of them Asgrow, and we've looked at different planting dates and different levels of management as a function of planting date. Now, I'll make a generalization here. This is just sort of a closing comment. I mean, I learned when I was a student that soybean had a higher minimum temperature required for germination than did corn. I learned soybean had to have 55 degrees to germinate. Corn was 50. By the way, that was completely wrong. They both will germinate at 50. That was when we were bin running seed, and now we have premium treated seed. If there's any single thing that we can do, what I've seen in our research is plant soybean before corn, because corn needs rapid uniform emergence for maximum yield, and soybean doesn't really care. And we cover that a little bit in our planting date study. That's the biggest factor that we've seen. And of course, we don't have to pay for the replant, so we don't care as much as Lance does.
And I would honestly say we have not seen a big trend that planting date has that big of an impact on your odds of replanting. Now, it does impact your risk of a freeze. So in some cases, the worst thing that can happen to you is your early planted beans come up in 5 days because they're going to get froze off if they come up quickly.
But as long as they have green cotyledons, you could frost off that unifoliate leaf. But as long as those cotyledons are green, there's an axillary bud at the base of each cotyledon, and there is a mechanism for regrowth. Right. It'll look ugly for a while, but what I've seen, remarkable ability of soybean to recover.
Unbelievable.
It's actually not a bad trivia question to ask which crop is more frost tolerant, because I would argue that soybeans can tolerate colder temperatures than corn. Now, we always used to say that, soybeans would be killed by a freeze and corn can recover from a freeze. Sometimes corn doesn't recover from a freeze.
No, that growing point below the ground is just a wives' tale.
So anyway, I think we've probably kept our viewers long enough. Thank you for hanging with us. Love the questions.
Don't forget about yield chasers, Lance.
If
you like hearing from Dr. Belo, there's an excellent opportunity.
That's right. So we will have again. Dr. Bilo with us again at our Yield Chasers Banquet, and NCGA corn yield results just came out a few days ago. Interestingly, kind of a down year for no 400s out there.
No 400s, all 300s.
So yeah, 394 something and change. I think DeKalb very well represented. Thank you to our customers that take the time to enter that contest, and it's always fun to see those results and look at that list of hybrids and our FSRs, Adam and Jennifer here. They are just braced for all these people that want to start buying this crazy stuff that they see winning in the NCGA yield contest. And I just remind you that that's a different world, different environment, very different management. Some of those hybrids that you see guys winning with in the contest might not be adapted to your farm. So just be careful with picking from that list of hybrids. So
we'll be back on the 12th as well of January.
12th of January, season 3. So we're not quite like The Voice. We're not up to 22 seasons or what. I don't understand how these shows have been on the air for 10 years can have 22 seasons. That math doesn't
I think they
make
do
sense.
twice 2 seasons a year.
2 seasons a year. It's like South America, I guess. You get 2 seasons a year. So we'll be back for season 3. Adam says it's January 12th. I hadn't looked that far ahead yet. Jennifer's standing here with a fishbowl worth of with all the names in it of everybody who's asked a question. And we're going to let Dr. Bilo draw a name out. So just to let you know how we did this, if you ever ask a question throughout the year, you've got your name in the bowl. And you know who you are, if you ask 20 questions throughout the course of the year, God love you and thank you for supporting Ask the Agronomist. You've got 20, your name's in the bowl 20 times. So we'll see if asking more questions improved your winnings here. So. Dr. Bilo.
This is going to look pretty suspicious when I pull my own name out of the bowl.
All right. Matthew Meyer is the winner of the solo stove this year. So Matthew would have been, I think, a multiple question asker, but not one of the 20 question guys. So those of you that have been stuffing the fishbowl trying to get the stove, I'm sorry, it didn't work out. It's kind of
way to go, Matthew.
Buying
didn't
1,000 lottery tickets, thinking you're gonna get the big winner. So Matthew, thank you.
He was a student of yours. I don't know if you remember Matthew or not.
What was his last name?
Meyer.
Meyer.
Yeah.
Oh,
So awesome.
Well
so
done.
I imagine you probably got a lot of former students that have been watching us here on Ask the Agronomist. So, but thanks again to everyone for participating. This has been a lot of fun for Adam and I to hang out with Dr. Bilo. Dr. Bilo, thank you very much for your participation here with us this morning. Very excited to have you back as a speaker for our Yield Chasers Banquet in February, right, Jennifer? February 2nd, I believe.
Groundhog Day.
So we are still, harvest is over. NCG yield contest results are out. Too late to enter the NCGA yield contest. Not too late to enter Groundbreakers. So we have extended that. And you may wonder, Dr. Bilo, nobody's harvesting. How can you still enter a yield contest? Well, within Field View, you can draw that field region report. And for our contest, unlike NCGA, all you have to do is circle a 10-acre spot in your field, and we'll even let you pick the best 10-acre spot in your field that you can find. So you can still enter our Yield Chasers contest.
As long as it's a DeKalb hybrid, right?
Yes. Yeah. If you're gonna
or an Asgrow soybean
or Asgrow soybeans, yeah. If you're gonna chase yield, you got to have the right stuff. So. Thanks for everybody for joining us. Everybody have a great holiday season. Merry Christmas. And thank you again, Dr. Bilo, for joining us here
My
today.
pleasure. Thank you.
And we always try to make Ask the Agronomist better. I'm not sure what we're going to do to top this one. We may have peaked too early, having our best ever episode in season 2. But thanks again, Dr. Bilo.
My pleasure. Merry Christmas, everybody.
All right. You're off.